question, on the first line, we're given two integers, say, n and m. Then, we're given m number of instruction lines as input, in which each line contains 3 values. We begin with a single-dimensional empty array R, all 0 values, of size n. Note that the index of this array begins with 1, and not 0. Each instruction line has 3 values. The first 2 indicate 2 indices in the single-dimensional array. Let's call the 3 values on each line A, B, and K, respectively. Our task is to add the K of each instruction line to every element of R belonging to an index ranging between the A and B of that particular instruction line. The final task is to return the maximum value from the resultant array, i.e. R. I know this sounds very confusing, but the example given below will clear things up. Explanation with example. Suppose we get the following input, 521,33155 here, n equals 5 and m equals 2. We start with a blank array R of size m, i.e. 5, 0, 0, 0, 0, 0, and perform the following tasks. Add 3 to all the index positions between 1 to 3. Add 5 to all the index positions between 1 to 5. So, first of all let's declare an array, R equals 0, 0, 0, 0, 0. We do so because the value of n is 5. Now, if we check the first instruction line, we get 1, 3, 3. According to the question, the first 2 values, i.e. 1, 3 are indices in whose range the third value, i.e. 3, must be added. So, we add 3 to the values in 1, 2, and 3 index positions of R. Thus, R becomes 0 plus 3, 0 plus 3, 0 plus 3, 0, 0, equals 3, 3, 3, 0, 0. Next, if we check the second instruction line, we get 1, 5, 5. Which means, we must add 5 to the values of our n indices, which fall in the range of 1 to 5. Thus, R becomes 3 plus 5, 3 plus 5, 3 plus 5, 0 plus 5, 0 plus 5, equals 8, 8, 8, 5, 5. This is the final resultant array. The largest value in the resultant array is 8. Thus, 8 is the final answer. Solution explanation. Naive approach. The most straightforward way of solving this problem would be to iterate through the instruction lines one by one, and at each iteration, run an internal loop from A to B for that instruction line, and add the K value to the values of R at those indices. This approach would work exactly as shown in the above examples. However, this approach would be too slow due to the presence of nested loops, and some of the larger test cases would throw a timeout error. Thus, we need to solve this problem with a linear approach. Optimized approach. Instead of running an internal loop for the given range in each instruction line and adding the K value to each of those indices, we could simply add the K value to the at the 8th index, and subtract the K value from the bth index. And while finding the maximum value, we declare a max equals 0 and a sum equals 0 variable. We iterate through the resultant array and add each of its elements into the sum variable. At every iteration, we check whether the sum variable is bigger than the max variable or not. If yes, then we set max equals sum. Let's understand this better with the help of an example. Taking the same input as previously used, 521,33155, we start with a blank array R equals 0, 0, 0, 0, 0. In the first instruction line, A equals 1, B equals 3, and K equals 3. Thus, we put our A equals our A plus K and our B plus 1 equals a b plus 1, dash k dot or, r1, equals 0 plus 3 equals 3, r4, equals 0 to 4 equals minus 4. R equals 3, 0, 0, minus 3, 0, in the second instruction line, A equals 1, B equals 5, and K equals 5. Thus, we put our A equals RA plus K. But as a B plus 1 is a 6, which is out of bounds, we do not take any further action. Thus, R1 becomes a 1, plus 5 equals 3 plus 5 equals 8. We get the final resultant array as 8, 0, 0, minus 3, 0. We set max equals 0, sum equals 0. Now we start iterating through the resultant array and adding its values in sum. At index 1, sum equals sum plus a 1 equals 8. Sum is greater than max. Thus max equals sum equals 8. At index 2, sum equals sum plus a 2 equals 8. Sum is not greater than max. Thus max stays the same. At index 3, sum equals sum plus a 3 equals 8. Sum is not greater than max. Thus max stays the same. At index 4, sum equals sum plus a 4 equals 5. Sum is not greater than max. Thus max stays the same. At index 5, sum equals sum plus a 5 equals 5. Sum is not greater than max. Thus max stays the same. We return max, 8, as the final answer. Code solution. The full code solution to the HackerRank array manipulation problem in Java and C++ are given in the description below. Result. I hope I was able to explain the solution to the array manipulation problem from HackerRank's interview preparation kit. If you have any doubts, feel free to comment down below. I will try my best to help you out. FAQ. ON, where N is the number of instruction lines.